Hello everyone and welcome to another tutorial on our channel. In this one we are going to be talking about the Java Stream API and we are going to be having a look at some examples from this library. So for all of you that do not know, Java Stream API is a powerful library that was introduced in Java 8 and it allows developers to process a collection of objects in a functional way. With Java Stream API, you can apply a wide range of operations to collections of objects, including filtering, sorting, mapping, and reducing. These operations can be chained together to form a complex data processing pipeline that are executed in a lazy and an effective manner. So you might ask yourself, okay, why is Java Stream API useful? Well, for one thing, it can make your code look more readable. So with Java Stream API, you can express complex data processing operations in just few lines of code, rather than having to write cumbersome loops and if statements. Additionally, Java Stream API is designed to be highly parallelizable, which means that it can take advantage of multi-core CPUs to process data more quickly. So how does it actually work? Well, at its core, it's based on the functional programming concepts such as lambda expressions and functional interfaces. This means that you can use lambdas to define functions that can be passed as arguments to stream operations. Stream operations can be divided into two categories: intermediate operations and terminal operations. Intermediate operations transform streams into another stream, while terminal operations produce a result or a side effect. But before we go into those operations, I would first like to go through some examples where we are going to look how we can actually create some streams. So let's go into our code that we have shown here on our screen. Okay, now let's have a look at our example and see how we can create some streams. Here we have our test class where we're basically just doing some examples and we're displaying it. For example, the first one is how we can create a stream from a collection. As you can see, we can call arrays as list to create us a list of strings, so a collection, and calling .stream on that collection will give us a stream of strings. Similarly, with an array, we can call array.stream with the array itself being passed in as a parameter, and this would give us a stream of strings again. And then we have a static factory method where we can create a stream of the strings which we pass in, again giving us the same result. Similarly, we have the thing with the builder. So from the stream builder, you can just add elements that you want and then call build, and this would give you the stream of strings. Of course, we can also do it with different types of objects. So for example, for integers, here we have the range defined, and then this gives us a stream of integers. And the last one is with the supplier, so you can pass in the supplier directly, and this again gives you the stream of strings. Yeah, so as you can see, it's actually quite simple to create a stream. Let's see now how we can do some operations with it. Let's take a look at the intermediate operations first. So the first one that we have here would be the filter operation. So we have a stream of some numbers, and we are filtering based on the checking if the number is even or not, and we want to only collect even numbers. So basically what this filter method will do, it will return a stream consisting of the elements of this stream. So as you can see, it will only return us a list of even numbers. And calling toList, so this is actually a terminal operation, so which gives us a list at the end and not stream. It will just collect them into a list, and yeah, this is what will be returned. Then we have a map operation. So in a map operation, we are going to be mapping so these strings, we're going to be mapping in this case to an uppercase string. So basically just converting this one to an uppercase string and then collecting it to a list and then just printing it out here. Then we also have a flat map. So basically here as an example, we have a list of lists. So these inner lists are lists of integers. And then we have one outer list which contains, so we have a list which contains a list of integers, and what we want to do at the end is just a list of integers. So basically we create a stream from the outer list, so the bigger one, so in this case we will have a stream of lists of integers, and then we call flat map, which will flatten it down, and then we will have a stream of integers, and then we just call to list, which will give us a list of integers. Then we also have a distinct. Basically we have a stream of some integers. We're calling distinct on this. We'll get rid of duplicates, so it will make a distinct list for us, since we're calling to list also. And similar example, we have a sort where we can just sort the stream. Okay, now we can also have a look at the terminal operations. So basically this will give us some kind of result at the end, not a stream. Here, for example, we have a stream of some strings, and we are calling for each, where we are just printing them out. So we are going to print each out. Then again, we have a stream, and we call a count on it, and this will give us a count of the elements of this stream. Then we have a minimum method that basically takes a look at these integers and finds the minimum one, otherwise it returns us a null. And then we also have any match or all match. Basically here in this stream we are checking if any matches this predicate here, saying okay, the number, so in this case any of these numbers, is greater than 3. So if any of these matches, this will be true. Of course, IntelliJ is complaining about it and saying, okay, this is false, because it already upfront knows what the elements here are, and it knows, okay, none of them are greater than 3. Same here, if all match, so if this will only be true if all of the numbers in this stream are greater than 3. Yeah, so this looks nice, but maybe it's better if we take a look at some real life example, or at least a mock of the real life example. So what I have created here is a couple of classes. So we have one called employee type, which basically is an enum, so full-time, part-time employees. Then we have a department, which is again an enum with 3 departments listed here, and then we have an employee class with some properties like name, how long the employee is employed, type of employee, so this enum, so it's part-time, full-time, and to which department it belongs. And at the bottom of this test, we have created a list of employees. So some kind of mock set of data, and then we do some operations on it. So we have our list here of employees, and in this one we want to say, okay, how can I get all of the full-time employees? So what we do is we stream it, so we call a dot stream on this list. Then we filter it. Okay, this is our employee, and we say, okay, filter only for the employees that have the type full-time. And then sort them by years employed. So basically meaning, okay, this should be the comparator which you should use when sorting the employees. So if you run this, we can see how it looks like. So we are only printing the full-time employees. So this first here, you can see it's being sorted by the years employed. So 1, 2, 5, 9, blah, blah. And they are all full-time. So we're printing the full-time employees here. Then let's say we want to see, okay, which employee that's part-time is employed the longest. So we again streaming our employees, we are filtering for the part-time employees, similar as we did here for the full-time, and then we are comparing, we're using again the years and the comparator, and now we are saying max. So similar as we did in this example here with min, now we're just doing with max, and then we are saying or else just return null, and here we are doing some null check for this employee here, and then just printing out its name. And also we can say, okay, I want to see, okay, what's the total years my employees are employed. Again, we are streaming them, then we are mapping to integer based on the years, and then we're just calling .sum and printing out the total. So as you can see, it's working with streams is quite nice, quite helpful in your code. So hopefully this tutorial will also help you out in your projects, and of course there are many more things you can do with this, so this is not everything. This is just like an entry level into Stream API, so to give you some hints how and what you can do with it. But if you're interested in more, of course you can find it online, or you can just leave me a question down below in the comments, or just send me an email. Email is in, you can find it on my account on YouTube. Yeah, thank you then for watching, and hopefully I see you in the next video.